So now we're going to see exactly what we just did in the previous video. And in the textbook, they call this, we just learned about the normal probability distribution and doing our z-score and looking that up in a z-table. We had ChatGPT give us a problem for that. And we're just going to reinforce that in this video and just go into that a little bit more. So the textbook, introduced us to normal probability distribution. That's everything we did in the last two videos. But then they also say there's this standard normal probability distribution. So instead of just normal probability distribution, standard is added in front of that, standard normal probability distribution. And the characteristics of a standard normal probability distribution, really in my mind, and for you learning this, just think about them as the same thing. But here's, just FYI, if you want to make the subtle distinction, a standard normal probability distribution is a random variable having a normal distribution with a mean of 0 and a standard deviation of 1. So that's a random variable. When it has a normal distribution with a mean of 0 and a standard deviation of 1, it's said to have a standard normal probability distribution. So when the mean 0 and the standard deviation is 1, standard normal probability distribution. So it's just, that's the standard. So the letter Z is used to designate the standard normal random variable. And, here is the standard normal probability distribution, mean 0, standard deviation, we should highlight these. Standard deviation, and mean, right? Mean is 0 and standard deviation is 1. And so Z is used to designate the standard normal random variable. And here's how you calculate Z. And that's just, the distance of a data point from the mean, kind of like how many standard deviations is that away from the mean. So we can think of Z as a measure of the number of standard deviations X is from the mean. And here's an example. So this is what we did in the previous one. Tire company has developed a new steel belted radial to be sold through a chain of discount stores. But before finalizing the tire mileage guarantee policy, Gear's managers want probability information about the number of miles a tire will last. And so it was estimated that the mean tire mileage is 36,500 miles with a standard deviation of 5,000, right? And the manager now wants to know the probability that the tire mileage X will exceed 40,000. So to calculate this, we could get our z-score. And so z is going to be equal to our data point, which is 40,000, minus the mean, which is 36,000, times 500. And we're going to divide that by the standard deviation of 5,000. And that's going to be equal to, what, 3,500. So it's going to be 3,500 divided by 5,000. Or that's going to be equal to 7 over 10. Because, you multiply this by 2, you get 10,000. Multiply this by 2, you get 7,000. And so you drop 2 zeros off of each of those. You get 7 out of 10, and that's going to be equal to 0.7. And so if we look at the next slide, 0.7. Okay, so exactly the same stuff. And then if you look on that z table at 0.7, so we have our z tables here, 0.7 is 0.7580. And in the slides, 0.7 is 0.7580. So these are just like z tables, which you could just Google, and it brings up an image of them, and you could use them. And at 0.7 standard deviations, positive 0.7 standard deviations away from the mean, 75.8% of our data will be to the left of that point. So we're looking at like this kind of a thing here, where 75.8% of our data is found to the left. That's the way z-tables work. Okay, it's showing your data from this point to the left, everything up to that point. So that is that's calculating the mean. So if we want to answer this question, compute the area under the standard normal curve to the right of z equals 0.7. It's going to be 1 because all of the data here is 1. And so if this is 0.7580 or 75.8%, then 1 minus that will give us what's here in the top. And the question that was asked of us is, want to know the probability about the number of miles a tires will last. Company has developed new, but finalizing, the manager now wants to know the probability that the tire mileage will exceed. So probability that the tire mileage will exceed 40,000 miles. So we want this, right? So at 40,000 miles, with that mean, I'm just going to get this picture and bring it over there. Boom. So at 40,000 miles, okay, here we go. At 40,000 miles with a mean of 36,500 and a standard deviation of 5,000, we have 40,000 to get our z-score. 40,000 minus 36,500 divided by 5,000 gives us 0.7. So that's 0.7 standard deviations away from the mean. And here, when we look that up, right, 0.7, 75.8% of our data, 75.8% of our data is from here over. So it's going this way, right? It's from here over is 75.8% of our data. And if I get a little text tool here and I could put that there, I could say 75.8% of our data. And I'm just going to make that smaller, like way smaller, like 8. And then just bring this in here. And I'll just make that like right there. So 75.8% of our data is from here over, which means that going this way, get my arrow and do it like this, like that, we have, and I'll just copy this and put it here. And I'll bring that up there, and I'll put it right here, and I'll say, you know, like what's 1 minus 1 minus 1 minus, right? Because it's total 1 minus 75.8% of our data is that way, okay? So that's going to be like 24.2% of our data is going to be that way. And so if you look down here, we get 24.2% of our data. All right, and so here's a picture of that. And the picture shows here is our mean of 36,500. And here's this data point at 40,000. And when we do our z-score, like here's, you know, this is like z0 corresponds to that. And so this is like doing standard normal. So I guess z-score kind of like equates everything to 0 for us. Because here we're dealing in like, you know, 0.7, right? So I don't quite get it, but whatever. So, you know, it's like kind of, it's all just the normal probability distribution to me. So here we have 0 to 0.7. And 0.7 is like the same, you know, that's the z-score we get with this value, 40,000, and that mean and this standard deviation. And so that means that from this point over, we have 75.8% of our data. And from this point over, we have 24.2% of our data. So 75.8, 24.2% of our data. So that's that one. So what should be the guaranteed mileage if Greer wants no more than 10% of tires to be eligible for the discount guarantee? Given a probability, we can use the standard normal table in an inverse fashion to find the corresponding z value. So wants no more than 10% of the tires to be eligible for the discount guarantee. So we go to our thing here, and no more than 10% is going to be like, we want 10%, but not anymore. So it's going to be like way over here, and it's just going to be 10%. So we're going to look for a negative where we have 10%. Here's 34%, here's 11%, here's 9%, here is 8%, here's 11%, 9%, 9%, 985, here's 10%. So it's going to be like pretty much like 1.28. So we have 1.2 here and 8 here. And so we're going to be at like negative 1.28. I'm going to do that, negative 1.28. And we'll go here. And we'll do z is equal to negative 1.28. And if our standard deviations on that, so we'll just do this here. We'll do z is equal to negative 1.28. And if our standard deviations on that, I'll just bring this down in size to like 10. Our standard deviations on that, what's our standard deviation on that? Our standard deviation is 5,000, right? So here's our standard deviation, 5,000, and that was given way back up in an earlier one too. So we'll do, standard deviation equals 5, 1, 2, 3. So 1.28 times 5, 1, 2, 3, and that's a negative. And we'll do this, and we'll do that. and then that's going to be a certain amount less than the mean. And so the negative, I think, already accounts for that. So we'll just take the negative out of that, and we'll take the mean. And the mean is, what was the mean? The mean is 36,500. So we'll do 36,500. 36,500 minus 1.28. That's 500. Minus 1.28 times 5,000, right? And so that should give us the number of miles where 10% and less of our tires will fall. And so we're going to get 30,100 miles, and that's equal to 30,100 miles. So here we have the mean, 36,500, 36,500. And standard deviation is 5,000, standard deviation is 5,000. So there's the mean, there's standard deviation. And then here, what's the guarantee? We want to offer it 30. So then they look up, you know, what we got to, what did we use? We used 1.28. So 1.28, we did this one right here. Let's see what they used. And they did 1.282, so 36,500 minus that is equal to 30,100. And that's exactly what we got, 30,100. So that's a guarantee of 30,100 miles will meet the requirement that approximately 10% of the tires will be eligible for the guarantee. So again, just kind of like putting this all into context, just remember what we're doing here is we're calculating probabilities. There's probability distributions. We have probability distributions for continuous data, continuous random variables, and we have probability distributions for discrete random variables. And for continuous, we have these three probability distributions. We have the normal, we have the uniform, we have the normal, we have exponential. And uniform is like, hey, you know, your highest value, your lowest value. And then normal, we use z-scores. And we look up to see at this point, this many standard deviations, either positive or negative, away from our mean, then a certain percentage of our data is from this point and to the left in that normal curve. And then we could use that to do problems like you've been seeing in the last couple of videos. Cool, so that's standard normal probability distribution.